Hi, my name is Fabio Vale. I am representing International Potash Institute IPI, and I'd like to present you the trial use of polyhalite to improve fertility in subsurface of acidic soils with coffee plantations in Brazil. My partner in this trial was Reagro Pesquisa from Nazareno, Brazil, and the researchers Vinícius Teixeira de Andrade and Daniel Veiga Soares. As introduction, I'd like to remember that coffee is a perennial crop. The fertility in the soil subsurface in this crop is difficult to be managed because all fertilization is made in top of soil. Okay, in acidic soils, liming is the main source of the calcium and magnesium to the crop, and in general, according because of the low mobility of the calcium and magnesium from liming, this action is restricted to the most superficial layer, which can reduce the development of the roots in the depth of the soil. For example, here, if I have a bad management of the fertility in acidic soils in depth, it's possible to have a calcium, magnesium, and potash deficiency in the depth, reducing the base saturation and incrementing the aluminum concentration in the depth, and the consequence, there is a reduction of the roots in the depth and the concentration of the roots of the top of the soil. It's a problem to nutritional problem, and a problem to plant take water. But if I have a good management of the fertility, I increment calcium, magnesium, and potassium depth, increasing base saturation and reducing aluminum concentration in the soil. Is very important to maintain the distribution of the roots and our profile of the soil. The objectives of this trial was to evaluate the mineral fertilizer polyhalite as a source of potash, calcium, magnesium, and sulfur for coffee, and its effects in the improvement of fertility in subsurface layers of acidic soils. Remember polyhalite. Polyhalite is a natural mineral, potash, calcium, magnesium sulfate dehydrated. This mineral is crushed, is screening, create a granular natural fertilizer, and is an exclusive commercial production in north of UK by ICL company, and with the commercial brand polysulfate. Characteristics of the product: 4 nutrients in your concentration, sulfur 19.2%, potash 14% of K2, magnesium 3.6%, and calcium 12%. Product has low salinity, is a prolonged availability of nutrients interesting characteristics, but the one important characteristic is the nutrients has mobility in the soil profile, because after dissolution are formed neutral ionic pairs, okay, calcium sulfate, magnesium sulfate, and the potash sulfate with neutral charge, and this neutral ionic pairs has capability to leach into the depth of the soil, incrementing the fertility in our soil profile. As material and methods, this trial was made with a partial and complete replacement of KCl by polyhalite, maintaining the same rate of K2O, 390 kilos per hectare of K2O, and increasing rates of calcium, magnesium, and sulfur. 7 treatments, and for applications according to stage 1, is possible to see treatment 1, 0 potash supply, okay? Treatment 2 is the total supply of the K2O by KCl, 650 kilos of KCl supplying 290 kilos of K2O. Treatment 7 is the opposite, total supply by polyhalite, 3,000 kilos per hectare to supply 290 kilos of K2O. And the treatment 3 to 6 are blends, polyhalite and KCl, increasing polyhalite and reducing KCl, okay, and maintain the same rate of K2O, but when I increase polyhalite and reduce KCl, I increase calcium, magnesium, and the sulfur supply. After having the coffee, 1 year after fertilization, the soil was analyzed, and at for dipths 010, 010, 020, 20, 40, and 40, 60 centimeters, and it was evaluating potash, calcium, magnesium, sulfur in all samples, base saturation and aluminum saturation in all samples and all dipths. The results for potash in soil, it's possible to see here in the dual graph I will show, but the green line is no fertilization with potash. The red line is the KCl as a potash source, polysulfate zero, polyhalite zero. The yellow is polyhalite 500 kilos per hectare. In black, polyhalite 1,000 kilos per hectare. Polyhalite purple, in purple is polyhalite 1,500 kilos per hectare. In blue, polyhalite 2,000 kilos per hectare. And in green, polyhalite 3,000 kilos per hectare. There is the mean tests made by Scott Knott test at 5% of probability. Capital letters here is comparing between fonts in the same dipty, then capital letters to compare in dipts, okay, and lowercase letters for comparison among the dipts with for each source. Capital letters compare in here, and lowercase letters compare here. Okay, it's possible to conclude that fertilizers increase the potash in soil, especially KCl increase only in the top of soil, but the polyhalite increase in top of soil and in all dipths. And interesting conclusion that despite the same rate of K2O, 390 kilos per hectare, polyhalite increment potash in dipty, but KCl no. It's possible to see here, KCl no increment potash in dipty, but the question is where is the K from KCl, because the rate was the same, probably the K was listed more deep than 6 centimeters, and I don't know if the plant has condition to use this potash. When evaluate calcium in soil in the same, it's possible to see that limestone no increment calcium deep, only the top of soil. Polyhalite increment calcium top of soil and in depth. And the increment was proportional to the polyhalite rate. Okay, and important to remember that the ideal is maintain the calcium soil higher than 2.5 centimole in soil, and it was possible to see polyhalite increase. Also, all rates of polyhalite increase calcium higher than the ideal in the top until the 20 centimeters, and the higher rates increment the polyhalite in the more in depth. Magnesium has a very similar results than calcium. Limestone no increment magnesium depth, polyhalite increment magnesium top and the soil profile proportional to the polyhalite rate, and the ideal maintain magnesium higher 0.9 centimole, and it's possible to see that polyhalite supply magnesium in the top of the soil and in the depth of soil, especially in the higher rates. Very interesting search to supply magnesium to the soil. As expected, polyhalite increments sulfur in soil profile with higher concentration, 20-40 centimeters layer. Okay, as expected, proportional to the polyhalite rate, increasing polyhalite rate, increasing sulfur concentration depth, and this concludes that sulfate was responsible for increasing calcium, magnesium, and potash in soil profile because according to comments some slides ago, the ionic pairs with the neutral charge formed that lead to the depth. Because we increment the nutrients in the depth, increment is base saturation too. Remember that base saturation is the calcium, magnesium, potash in CC, okay, calcium exchangeable capacity. When I increment calcium, magnesium, potash in CC, I increment the base saturation. Remember that relation when I increment base saturation, increment pH of soil in the reduced acidity, then it's possible to conclude that when I apply the polyhalite, I reduce the acidity in the depth, very important to the crop. And I increment the base saturation proportional to the rate applied, and it's a big problem in coffee areas where the base saturation is low than 50% in depth. It's possible to see that uh, a big problem when I use KCl as potash source, because the base saturation in the depth is very low and problematic to roots development. And the opposite, if I increase base saturation, I reduce the aluminum saturation. It's possible to see that polyhalite reduce the aluminum concentration and aluminum saturation. The difference in comparison with conventional fertilization with KCl here, and the increment of V% reduce the M saturation. Perfect. This there is possible to see that the normal fertilization increment the potential to increment the increase the aluminum concentration, and according I said in the beginning of this presentation, maintain the roots more superficial and could be a problem to the plant. As conclusion of this trial was the polyhalite significantly increased the contents of potash, calcium, magnesium, and sulfur in all depths, increasing base saturation, reducing aluminum concentration in soil profile, proves to be an interesting option for be used in a partial or total replacement of KCl in acidic and base poor soils in depth. Okay, coffee and the other perennial crops in Brazil and the other countries of the world. As acknowledgement, I'd like to have ICL to supply the search to do these trials and to Reagro Pesquisa to conduct the trial at the field. Thank you.